Okay, so we're going to finish up chapter 4 here, and we're going to talk about graphing absolute value graphs. And we're going to talk about them in the idea of transformations. How can I transform a basic absolute value graph based on what I'm adding to an equation? And then we're going to use those same ideas and we're going to transfer them back to lines. So an absolute value graph looks like a V-shape. And the whole reason why it looks like a V-shape is because when I draw a table, an XY table, when I plug in a negative number, like -2, the absolute value of -2 is +2. And when I plug in a -1, the absolute value is +1. When I plug in 0, the absolute value is 0. When I plug in the number 1, absolute value keeps it positive. And so we're getting this V shape where normally if we had an equation that looks like y equals x, that line would keep going this direction down here. But because absolute value turns all these numbers positive, they now, this little bit shifts up here to create this V shape. And with our V shape, we have a special point, the very corner of the V. This is called our vertex. When we're graphing absolute value shapes, we're looking at where our vertex is. And our vertex in this original function, this is what we would call a parent function. And that parent function is y equals absolute value of x. There's no extra numbers in there. That's why it's called a parent function. It's our basic absolute value graph. And the vertex of this one is 0, 0. Now the slope of my line, we kind of look at our slope like we do slope of lines. So this one, I go up 1 over 1 on this side. So it's like an up 1 over 1. But that's over 1 to the right. I also, though, because of the absolute value, I go up 1, left 1, up 1, left 1. So it's almost like I've got a -1 and a +1 slope. And so the way we describe this is a slope of 1. And so it's up 1 and over 1 both directions. And that's what we're going to do with our absolute value, is it's up 1, over 1 both directions. So from here, up 1 over 1 both directions. And then from here, up 1 over 1, and then up 1 over 1, and then up 1 over 1, and then up 1 over 1. And so we just keep doing that, so that way we get that whole idea of absolute value and reflection. So how does our absolute value graphs change? So this is the values that we know. This is how we look at our absolute value graphs. It's called the transformational form. And the transformational form is really important because each number, or right now it's a letter, describes how our graph change. So what we have here is we have an h value, which will be the x value of my vertex. My h value will move the graph left and right. Just like the x value moves left and right. Then I also have a k value over here, and that is the y value of my vertex. And just like the y moves up and down, this will move my graph or my vertex up or down. And then the a, which is the number in front of the absolute value, that is my slope. So if my slope is negative, that means my v is going to open down. If my a is 2, that means I'm going to go up 2 over 1 in both directions, up 2 over 1, and keep going out and out and out. And so that's kind of my idea. And we're going to take a better look at this because we're going to look at describing how, by looking at my equation, how does my graph change. But let's work through a couple problems first, just kind of getting an idea of how this works. So if I were to graph this equation, my vertex would come from here. And so remember, we're looking at this equation y equals a absolute value of x minus h plus k. That means that when I'm looking at this minus h, because of the minus, I change the sign. So if this is a minus 5, for my vertex, I change the sign. And then because it's plus k, I keep it exactly the same on this last number. So the vertex, or that very point of my V shape, is going to occur at 5, -3. So x value 5, y value of -3. This is that point. That is that V of the vertex. But now what I have is I have a slope, and my slope is 2/1, which means I'm going to go up 2 and over 1 in both directions. So from here, I go up 2/1 this direction, up 2/1 this direction. And then I'm going to keep doing that. So on this side, I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. But on this side, I'm going to go up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. And so this gives me my absolute value graph. And so we can kind of see how my original vertex started at 0, 0. And what we did is by minusing 5, we shifted that vertex over here, 5. So to the right 5, then we've shifted down 3. And then instead of having the up 1/1, this is what it would look like if it was up 1/1. It actually is steeper. So what we end up doing is we take this point and we stretched it up. We stretched it up. We stretched it up. And that stretch up is called a vertical stretch, because up means vertical. And then we're pulling it up, and so that's a stretch up. Okay, so let's go ahead and look at our next graph. We have our vertex coming from here. So -3, +8. So my x value is -3. My y value is +8. And then we have a slope of -1/2. So that means I'm going to go down 1 and to the side 2 in both directions. So down 1 over 2, down 1 over 2. And then I'm going to keep going. So on the right-hand side, I'm going to go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. On the left-hand side, I'm going to go down 1, left 2, down 1, left 2, and that's going to give us our V. And so notice that that negative makes my graph open down. And so instead of opening up, we're opening down, and we've got special names for that. And again, we're going to talk about that in a minute. And then if we look at the vertex, so our original vertex was at 0, 0, and then we shifted it to the left 3, and then up 8. And we can see that, left 3, up 8, just from our vertex of what was happening there. And so I've got a little thing that I can show you that really isolates and lets us see how these graphs occur. So this is a program that when you're in geometry, your teacher will probably use it. It's called GeoGebra. It's a free online program. And what I have right here is I have that original graph, y equals the absolute value of x. And so I'm also going to graph in green the equation. And what I'm going to do is the green one's going to change. So we can see how the green one changes compared to the original. Right now they're on top of each other. So we get this like baby poo green color. And hold on, let me get some points on here. Green, green, and green. And then I'm going to go ahead. And we're going to move it around. So remember how we have this A value, the H value, and the X value? So let's alter our H value. Let's go ahead and change the H value to +1. But remember, here it says -1. So +1 for H means that in my graph, we're going to see this -1, and it moves it to the right 1. And 2 moves it to the right 2. 3 moves it to the right 3. 4 moves it to the right 4. We can even probably go to 5. And see how that changes in our equation. As I move it, it's changing that in my equation. So when it says -5, I'm actually moving it the opposite direction, +5. And that's how we're seeing that that switch happens. Now I can even go the opposite direction. Boom, there's 0, and then minus -1. So remember how we changed those to plus? -2, -3, -4, -5. So the H value is moving us side to side. So let's get back to 0. Now let's look at that K value. Look at how the K value changes. When I do 1, it's up 1. And look at this equation. Look how it says +1. So that's not changing. +2 is up 2. +3 up 3. And then when I change it to negative, it's moving it down. And look, it's still negative in my equation, kind of showing how that relationship works. Now, let's go ahead and change this to +2, -3. See? So we're seeing that. And then we can also see the changes in our point values. So the B that has the original 1, 1, my new B has 3, -2. Okay, so we're going to go back and we're going to look at this 0, 0. Come on. Let me move this. There we go. Move this back to 0. This back to 0. Okay, now let's look at our A. So this is, remember, is our slope. And if I make it negative, here, there's negative, and now all of a sudden it's opening down. And when I look at it opening down, it's like flipping across that x-axis. And so anytime it's negative and it starts opening down, we say it's a reflection across that x-axis. So let's go back. Now look, when my values are small, look, 0.2, look how wide it gets. You would think that with a small value, it wouldn't get so wide. But the smaller the value, the wider it is. And then as I get closer and closer and closer to 1, it gets less and less wide. And then when the number is 1, it looks exactly the same. Now, as it gets bigger, 1.1, 1.3. So as my numbers are bigger than 1, then it starts getting skinnier. And if you look at that the points B and C, they're becoming stretched up. Stretched up. So that's what we call it, a vertical stretch. It's stretching that up and it's making it skinnier. But as we get smaller, it's pushing it down. So it's compression. It's pushing those C points and those B points down. And so it's a compression. So when it's small numbers, it's compression. So less than 1 is compression. Greater than 1 is a stretch, stretching it up. And so we're using that idea to help describe what's happening to the graph. Okay, so let's now go back. And here's your little cheat sheet. The cheat sheet on how to describe this. So our H value is going to move it left or right. And we call that a horizontal shift. Kind of like the horizon goes side to side, kind of like the x-axis. That's what our H value does. It moves it side to side, right or left. And then we also have the K value. The K value is going to move it vertically, up or down, which is what we call a vertical shift. Now a negative A value is going to cause the graph to open down, and that's what we call a reflection over the x-axis. So that's our opening down. And then we have an A value between 0 and 1. So these are our small numbers. It's going to widen my graph. And that's what we call that vertical compression. Because remember, those numbers came down lower than my original graph. And so it pushed out that graph and made it wider. And then we also had an A value greater than 1. That's going to cause it to become more skinny, more narrow, and that's called a vertical stretch. So we have some examples here of going over what's happening. So this is my H value. So this, let's actually color code that. So my H value was green. So this is my H value. And so that's going to be my horizontal shift. So this is a horizontal shift. And remember, I changed the sign of these ones because of the way that works. So this is a horizontal shift of +5, which means that I'm moving my graph to the right 5. Now my K is right here and in yellow. I should probably pick a different color to write that in though. We're going to go ahead and write that as K. So this is our K. Here's K. And our K value is -3. Now K represents a vertical shift. So this is a vertical shift of -3, which means I'm moving it down 3. Now we're going to our A value. So our A value is right here, and that's 2, and 2 is actually greater than 1. And since 2 is greater than 1, it's going to be a vertical stretch of 2. And that's how we describe what's happening to that graph. And this is really important because you're going to do a lot of this as you move up the math ranks. So Algebra 2 is kind of the goal because if you're going to college, that's your basic college algebra class. And you'll be doing a lot of this in Algebra 2. So having the good basis for this, the vocabulary, is going to be helpful for you. And we're also going to do this with lines. We're going to do this with quadratic equations and other things. So we'll keep seeing this. So let's look at our next problem. Let's look at our H is +3. So our H is a horizontal shift of, and then we change the sign with the horizontal ones, remember? So this is -3, which means I'm moving left 3. Then we have our K. That's going to tell me my vertical shift. So my vertical shift is 8. Which means we're going to move up 8. And then we have several things going on with our A. The first thing we have is a negative. And negative means it's going to open down instead of up. So that's our reflection over the x-axis. And then I look at this 1/2. Now 1/2 is between 0 and 1. So because it's between 0 and 1, it's going to widen my graph, which is known as a vertical compression. Okay, so that's our description. So on your worksheet, you're going to be writing these descriptions, or on your in class, you're going to be doing this. You're going to be writing these descriptions and you're going to be graphing it. So let's go ahead and look at our equations. We're going to describe and we're going to graph. So let's go ahead and look at our H value. Our H value is 1. So we're going to have a horizontal shift of +1, because remember we changed the sign on the H value. Then we're going to look at our K value, a -7, and that's our vertical shift. And so that means we're moving it down 7. And then we have the negative, so we reflect over the x-axis. And then the 3 is bigger than 1, so it's a vertical stretch of 3. So we have several options here. We can use the descriptions to graph, or we can use the first method we had at the very beginning, where my vertex comes from h and k. So my h value is +1, my k value is -7. So I can take this vertex and I can do a horizontal shift of +1, so horizontal shift +1 to the right 1, vertical shift of -7, so down 7, and that gives me my vertex. And that tells me the same thing that mapping out my vertex did. Now from here, we have our slope. So our slope is -3, which means from here I go down 3 over 1 in both directions. And there's our graph. Also, our description, reflect over the x-axis, means opening down. Vertical stretch of 3 means these points, instead of going up 1 over 1, now goes 3. So from here, down, but 3. And it's all just special language to do the exact same thing we have been doing. But you have to know the language so that when they ask you to do these things, you understand how it works. So let's look at our next problem. Let's look at our h value, which is -6. So I can go down here and put in -6 and describe it. It's a horizontal shift, which means side to side, of -6, which means I'm going left 6. My k value, -5, is the y value of my vertex. It means that I'm going to have a vertical shift of -5, which means going down 5. So right now I could go ahead and graph that new vertex. So this vertex moves now horizontal shift of -6, so -6, vertical shift of -5. There's my vertex, and it is the same as that point. Now we're going to address that slope. So our slope is 3/2. Is it bigger than 1 or less than 1? Well, it's bigger than 1, so it's a vertical stretch of 3/2. And I leave it as the fraction. I could say vertical stretch of 1.5, because that really illustrates that it's bigger than 1. But when I graph my slope, I want to use up 3 over 2 from here. So I'm going to go up 3, 1, 2, 3 over 2, up 3 over 2 the other direction, and then I'm going to keep doing that. So on the right-hand side, up 1, 2, 3, right 2, 1, 2, 3, right 2, 1, 2, 3, right 2, 1, 2, 3, right 2. On the left-hand side, I go 1, 2, 3, left 2, and then I run out of room. And that's the end of our absolute value graphs. So we're looking at translations, we're looking at how to graph them, and we'll keep practicing these in class.